Today we're learning about geometric sequences. So yesterday we did arithmetic sequences. And how can you tell if something isn't arithmetic? Well, it has a common difference. Has a common difference. Forget that. So which one of these have a common difference and which ones don't? Try to decide. Take a second and figure that out. Okay, these all have a common difference of 3. So it is a arithmetic sequence. This one goes up by 5, then 10, then 20, so it's not. This one goes down by 5 every time, so it is, and this one just goes positive, negative. That's not arithmetic. So the difference between arithmetic and geometric is arithmetic you add to get to the next term. Geometric you multiply. So you're going to multiply to get to the next term. What you multiply by, that was probably pretty loud for you, sorry. What you multiply by is a common ratio. So that's what you're actually multiplying by. Okay, so to find the common ratio, we divide one term by the term before it. So that's it. So you take, if I tell you this is a geometric sequence, I take 10 and I divide it by 5, and that's what I got. Now, most of the time you can probably figure it out that you multiply by 2 to get to the next term, but this is the official way of figuring that out. Okay, if you have fractions, you still would do the same thing. With this one, there's 2 of them that aren't, so it's negative 3 divided by 6. So negative 1/2 is your common ratio. This is your R. Okay, so you can figure out the common ratio and then find the next term of the sequence. In this case, we want the 7th and the 8th term, so take a second and find those. Okay, for this one here, you can find that the common ratio was 3, so each one of these you had to multiply by 3 to get to the next term. This is 1, 2, 3, 4, 5, 6, 7th term. For this one, you had to multiply by 1/3. Another way to think about it is that you are dividing by negative 3. So what happens with this one is it's positive, then it's negative, then it's positive, and then it's negative, because every time you have 2 negatives, it becomes positive again. So that's the interesting thing about geometrics and how it works. So when I go through, the 8th term is negative 1 over 2187. All right, so just like in arithmetic, we had a formula to find the nth term of a sequence, to find that explicit formula. So remember, when they say nth term, sometimes they write it all in one line like that. I know it looks weird, but it says nth. That means the explicit formula. That means n is still in the problem. Okay, so this is the explicit formula, where R is the common ratio. So we want to find the formula to find the 9th term. Now I know you could find the 9th term just by doing it, but let's just use the formula here. So we figure out what the R is. R is 6 over, excuse me, I've reduced already. It's 6 over 4. And then, so that's like 3 over 2. It doesn't matter which one you put in, I just like that one. We want to find the 9th term, so a sub 9. We're putting 9 in for n. So the first term is 4, so I put that. The common ratio is 3 over 2, that R. Again, I'm just following this. Just A1 is 4, R is 3 over 2, and then n minus 1, so 9 minus 1. That's 9 minus 1 that goes there, or 8. Simply plug that into your calculator, and you get 102.52. I think. All right. So now, given 2 terms, can you find the common ratio? So not just 2 terms, like not just one right after the other, but 2 terms where one is the first term, I guess. So we just use the formula again, just like we did yesterday with arithmetic. Okay, so we're going to do like, okay, T5 is equal to T1, now times the common ratio, which I don't know, to the 5 minus 1 power. So I'm going to put the pieces in now. T5 is 3 over 8. T1 is 6. We don't know what R is, but we know the exponent is 4. So divide by 6, and you get 1 over 16 is equal to r to the 4th. Now you could, yeah, there's no other way to do this. You do to the 1/4 power. Remember, you flip your thingies, and you should get 1/2. Okay, for this one, take a second and see if you can figure that out. Do it the same way I just did. And okay, so this is what this one looks like. T4 is equal to T1 r to the 4/3. Plug all the pieces in. Remember, T4 is this one, T1 is this one. Divide by 6, flip the exponent, and you should get the r is -3/4. Okay, so this is just all the different ways we can use this formula. So let's get to it. Given the following terms of a geometric sequence, can you find the third term? So it's the same basic thing as yesterday. Instead of finding the common difference, we have to find the common ratio. And we need our A1. So we know A1 is 2. We don't know what the common ratio is, so we need to figure it out. So take a second and figure it out. Okay, so R, we just use the formula. We plug in 8 for A sub, A sub 8 for A sub n. Plug that in, divide by 2, flip the exponent, and you should get 3 as your R, your common ratio. So then to find A3, all we need to do is find A3. So it's the first term times the common ratio to the 3 minus 1 power. So simply put that in your calculator and you should get 18. Okay. What is n? Okay, for this one, same idea. I'm telling you what the common ratio is, so we don't actually have to find it. That's nice, but that's the first thing you should always look for, is that common ratio and the first term. These are the two things that you need every time. So I have those two. So, but I don't have A sub n. Well, I have A sub n. I don't know what n is, let's say. So when I use my formula, A sub n equals A sub 1 times r to the n minus 1 power, I'm going to replace A sub n with this, but I'm not going to have an n for an exponent. So remember what we do when we solve for exponents. That's right, big guys. Okay, so divide by 5, and I get 729 equals 3 to the n minus 1 power. I'm sorry if this makes noise when I hit it. This microphone is a little bit more sensitive than my other one. Okay, so what we have to solve this. So to solve for exponents, there's two routes to take. You can get the same bases, or you can use logs. Either one will work. In this case, I know that 3 to the 6th power is 729, and then it's 3 to the n minus 1. So these get dropped, and n minus 1 equals 6. Oh, n minus 1 equals 6, so n equals 7. Now you could use logs on the next page. We're going to use logs, so you'll still see it. Okay, so for this one here, this is a word problem. So with word problems, and anytime you're dealing with rate, we have to remember our percent rate of change. And in our formulas, the percent rate of change that we have here is never 20%. Remember, when we put this into our formula, like our 1 plus or minus the r to the n power, or the t power, whatever, we're always adding or subtracting 1 from that or to that. So that's the one thing you have to remember when you're dealing with the percent. When they give you a rate of change, but it's still a geometric sequence. So you need to add or subtract 1 to the rate and to put that into your formula for your rate common ratio. So the common ratio is what we have to figure out. And then, what the first term is. Well, I know the first term is 5120, because that was happening. This is 1. And then this is going to be the second one. I'm looking for the second one, A2. So 4 years later, they say this happens every 4 years, it increases. So 2006 is actually our A2. So the common ratio can be figured out by taking that 20% change it to a rate here. And since they increase, I'm going to do 1 plus the rate. So since it's increase, it's a growth equation, so it's 1 plus 2.0. Okay, which is 1.2. So to figure out this formula, we just do 5, 1, 2, 0, the first term, times the common ratio. Cancel. Sorry, some weird thing happened. Times the common ratio, and then to the n minus 1 power. So this is our n, so this is to the first power. So a sub 2, or 2006, is 6144. Okay, writing an explicit formula, that's pretty straightforward. I know it doesn't seem like it should be, but geometric sequences are actually easier. So an explicit formula, remember you keep n in the equation. So then we do the first term, 5120, times the rate, 1.2, to the n minus 1 power. There's literally nothing else you can do. You're done. So then use the explicit formula to know, to find out what year there'll be at least 10,600 accidents. At least. So I guess there could be more. So 10,600. So what is that? Is that the n? Is that the time? Or is that the actual accidents? Well, that is your a sub n. So you're trying to find out the term, how many sets of 4 years that happened. So that's your y, if you want to think of it that way. We don't know what n is, so it's n minus 1 there. I'm going to make this a little larger because I'm going to run out of room. Okay, we're solving for an exponent, so that's right, you guessed it. We got to use logs. So this is some number like 2.070. Okay, and we're going to bring that n minus 1 down and do log of 1.2. So I just took the exponent on this guy and brought it over to here on in front of the logs. So now I divide by log of 1.2, and I'm left with about 3.99, and times n equals n minus 1, so I'm simply going to add my 1. So it would be 4.99, or in 5 terms. Term 5. Now that's 5 terms, that's not 5 years. Okay, so they said up at the top that every term is 4 years here. So since every 4 years it increases by 20%, and we started in 2002, every term is 4. So I have to do 4 times 5, which would be 20 years. So in what year would that be? Well, that's be 2002 plus 20. So that would be 2022. All right, this one is just a breakdown. We'll go over it in class tomorrow, just to make sure you understand. It's just all there, reminding you of all the different things, how you find the R, and things like that. Have a great day.